Linux and Cybersecurity for Beginners by Google. Let's check it out.
You might have seen or heard the name Linux in the past, but did you know Linux is the most used operating system in security today?
That's interesting. In security, maybe. I guess. I mean, one, it's free. Two, it can be more powerful and less obnoxious than Windows. So sure. Alright, I'm tracking.
Let's start by taking a look at Linux and how it's used in security. Linux is an open source operating system. It was created in two parts.
Open source meaning these are projects that people like you or me, or perhaps people with more skill than me in programming, were able to design and put out there for all of us to enjoy and to use without having to, open up our wallets to give to our Microsoft overlords.
In the early 1990s, two different people were working separately on projects to improve computer engineering. The first person was Linus Torvalds. At the time, the Unix operating system was already in use. He wanted to improve it and make it open source and accessible to anyone.
It's honestly people like that have made the world such a better place rather than, I get it. We need corporations to give us jobs and so we have employment and can pay our bills, right? Salaries are important. But open source software has changed the landscape so drastically, and it's people like this that aren't trying to be greedy with money. Again, I'm a capitalist, nothing wrong with, making a buck off software you created, but open source software has been a game changer for the industry and honestly for the world.
What was revolutionary was his introduction of the Linux kernel. We're going to learn what the kernel does later. Around the same time, Richard Stallman started working on GNU. GNU was also an operating system based on Unix. Stallman shared Torvalds' goal of creating software that was free and open to anyone. After working on GNU for a few years, the missing element for this software was the kernel.
Alright, so we just got a history lesson here from Google, which is great. Google training, this is a little bit slow. We probably want to put this on 2x speed, but we're doing some commentary, so we won't. Knowing the history of operating systems might not be useful in your day-to-day, but it's super helpful in living the lifestyle and emulating, knowing who your heroes are, who your predecessors are, who came before you, what their goals were, to help you align and think about your own set of values when it comes to jumping into a career like cybersecurity. This is unlike other careers in that you're not alone. We are in this together and we're building a community together. And these are some of the forefathers that really helped make that possible.
Together, Torvalds and Stallman's innovations made what is commonly referred to as Linux. Now that you've learned the history behind Linux, let's take a look at what makes Linux unique. As mentioned before, Linux is open source, meaning anyone can have access to the operating system and the source code.
This is, if you can't afford, if you have an old computer and your Windows no longer works, you can just re-image it and throw Linux on there. I have a ton of old laptops. I don't throw any of them away. You can just put Linux on them, and now you got a computer. It's because it doesn't have all of the bloatware, or at least some of the Linux distributions don't have all of the bloatware that comes with Windows. Man, slap that bad boy on, and you got another usable computer. Or at least extend the life of it a little bit.
Linux and many of the programs that come with Linux are licensed under the terms of the GNU public license, which allow you to use, share, and modify them freely. Thanks to Linux's open source philosophy, as well as its strong feature set, an entire community of developers has adopted this operating system. These developers are able to collaborate on projects and advanced computing together. As a security analyst, you'll discover that Linux is used at different organizations. More specifically,
some of this stuff is pretty slow, but in general it's true, right? The flavors of Linux are going to be everywhere, and that's what somewhat makes it difficult in cybersecurity is one company may use Oracle, another company may use Red Hat, another one Ubuntu, you might use Kali. They're all flavors of the same Linux, of the same operating system. Once you learn one, the skills are pretty transferable, but some of those commands are actually different, which is kind of frustrating. The first time I tried Parrot operating system, I'm like, why does this not work like Kali? All of the same commands I'm using, apt update, things like that, have slightly different syntax that you got to learn. So consider that when you're swapping companies and they use a different type of Linux. Got to get used to that new structure.
Linux is used in many security programs. Another unique feature about Linux is the different distributions or varieties that have been developed. Because of the large community contribution, there are over 600 distributions of Linux. Later, you'll learn more about distributions. Finally, let's take...
There might be more than 600 flavors of Linux, but if we're going to be honest, there's like 12 that are the top dogs in the industry, whereas those other, 588, however many, right, are someone like you and me can create our own, package our own distribution, and that's what a lot of professionals above my level, right, those people that want their own particular flavor with their own tools, and it's just out of the box ready to go for them, they'll create their own. These are not necessarily enterprise ready distributions that you would use. They're, like I said, there's only about a dozen of those that you'll likely see at most enterprise companies.
Take a look at how you would use Linux in an entry-level security position. As a security analyst, you'll use many tools and programs in everyday work. You might examine different types of logs to identify what's going on in a system. For example, you might find yourself looking at an error log when investigating an issue. Another place where you will use Linux is to verify access and authorization.
Yes, I mean, you can use Windows to go through logs as well, and oftentimes you can use, let's say if you're doing Windows, you'd use let's say PowerShell. You could dig through the logs that way. You can do the same in Linux, but generally speaking, at a company, at an enterprise company, they're going to have a software solution that can parse those logs better than you would do otherwise. Right? There are free tools like Wireshark where you can parse logs, but you're going to get something probably called a SIM, Security Information and Event Management, which parses those logs for you. And granted, it's not going to be for, like what she was saying, error logs. It could be if you're ingesting error level logs into your SIM. But like Linux doesn't have a market cap on, or lockdown on logs. But there's no like one-to-one correlation. You need to know how to do that regardless of the operating system.
Identity and access management system. In security, managing access is key in order to ensure a secure system. We'll take a closer look into access and authorization later. Finally, as an analyst, you might find yourself working with specific distributions designed for a particular task. For example, you might use a distribution that has a digital forensic tool to investigate what happened in an event alert. You might also use a distribution that's for pen testing and offensive security to look for vulnerabilities in the system.
Absolutely. That's one of the nice things about having a distribution is you can just spin up a new instance of, say, Kali or Parrot OS, and it has the tools that you need ready to go. And this is great at entry level, even into intermediate, where you just want all of the tools prepackaged. You got the ISO file that you just downloaded, slap it onto a VM, and you're good to go. Just makes it so much easier, and it really speeds up that process of, okay, I don't need to figure out what tools do I need, how do I download them, get my own. Like I said earlier, that's something that you'll probably do as you niche down further and further and you know exactly what tools you need. So even a distribution like Kali Linux has a ton of bloatware, a ton of tools that you're unlikely to use. So stripping all of that away is likely something that you would do down the line.
Of their users. I hope you're excited to learn more about Linux. This will be a very useful skill in the security field. Let me start with a quick question that may seem unrelated to security. Do you have a favorite building? And what is it about its architecture that impresses you the most? The windows? The structure of the walls? Just like buildings, operating systems also have an architecture and are made up of discrete components that work together to form the whole. In this video, we're going to look at all the components that together make up Linux.
That's a funny analogy. Your favorite even if you have a favorite building, you're still going to enter other buildings. Just as you might have a favorite operating system, a favorite flavor of Linux, or it could be Windows, could be Mac OS, you still need to know the other ones. You can't just stay in one building your entire life.
The components of Linux include the user, applications, the shell, the file system hierarchy standard, the kernel, and the hardware. Don't worry, we'll go into these components one by one together. First, you're the user. The user is the person interacting with the computer. In Linux, you're the first element to the architecture of the operating system. You're initiating the tasks or commands that the OS is going to execute. Linux is a multi-user system. This means that more than one user can use the system's resources at the same time. The second element of the architecture is the applications within a system. An application is a program that performs a specific task.
Again, this isn't really different than Windows. Most of this information is just going to be copy pasta onto Windows. Windows also has applications that perform specific tasks. Many of those applications are also available on Linux. Not all of them, but some of them will be.
Such as a word processor or a calculator. You might hear the word application and programs used interchangeably. As an example, one popular Linux application that we'll learn more about later is Nano. Nano is a text editor. This simple application helps you keep notes on the screen. Linux applications are commonly distributed through package managers. We'll learn more about this process later. The next component in the architecture of Linux is the shell. This is an important element because it is how you will communicate with the system. The shell is a command line interpreter. It processes commands and outputs the results.
Again, Windows has the same. It's called PowerShell.
This might sound familiar. Previously, we learned about the two types of user interfaces, the GUI and the CLI. You can think of the shell as a CLI. Another element of the architecture of Linux is the File System Hierarchy Standard, or FHS. It's the component of the Linux OS that organizes data. An easy way for you to think about the FHS is to think about it as a filing cabinet of data. The FHS is how data is stored in a system. It's a way to organize data so that it can be found when the data is accessed by the system.
This part you actually really need to know. If there's one thing you learn about Linux, you need to understand the filing system, because it's similar to Windows in the sense of how you can navigate around, but it has a different naming convention, and you need to know where all of your useful, and there's so many files that are analogous to Windows, but different because of that naming convention and where they lie. So be sure, you got to figure that stuff out, especially if you're trying to do capture the flags. Where are people hiding flags? How can you see permissions on folders? Certain things like this, you just got to figure out. Super important as an analyst. Even though, as an analyst, we're not capturing flags, sure, as our day-to-day job, but we are looking for clues, hints, secrets, hidden files, things like that.
Access to the kernel. The kernel is a component of the Linux OS that manages processes and memory. The kernel communicates with the hardware to execute the commands sent by the shell. The kernel uses drivers to enable applications to execute tasks. The Linux kernel helps ensure that the system allocates resources more efficiently and makes the system work faster. Finally, the last component of the architecture is the hardware. Hardware refers to the physical components of a computer. You can compare this to software applications, which can be downloaded into a system. The hardware in your computer are things like the CPU, mouse, and keyboard. Congratulations!
That was an interesting 3 items to name: CPU, mouse, and keyboard. But again, the hardware is actually going to be basically the same in Windows, right? On my same computer, I can install Linux as I could install Windows. Can't install Mac OS. That's where your architecture, your hardware, is really going to differ drastically. But Linux and Windows can often just use the same hardware.
We've now covered the architecture of Linux. An understanding of these components will help you become increasingly familiar with Linux.
Good stuff by Google. They have really great training. Highly recommend, especially if you're new. Their cybersecurity certificate is I have their Google IT support certificate, and it taught me so much. Really, in the beginning, when I knew nothing, it brought me from zero to beginner in things that you wouldn't even think of. So highly recommend, check them out, go through their series, and you'll learn a ton. Thanks for watching, and I'll catch you in the next one.